Hi guys, how are you? You find me in a rare situation today. I've managed to finish my job. I've actually had time to go and get my hair cut as well. And I've got a quick few minutes to be able to talk you through the engine bay on the TT. So, obviously we need to go in the driver's side and pop the bonnet to show you what goes on inside the engine bay. That's the handle just down here. Good pull. Just in here you'll see the latch just there. We'll just give that a lift and it's got automatic struts. Now I'm going to try and keep this video really basic, reason being that I'm getting a lot of questions, and I'm getting involved in a lot of questions that people are asking on the forum about certain things, and fault finding and all stuff like this. And a lot of the time, we're trying to ask people to disconnect the N75, disconnect the MAF, things like this, and people don't know what they are sometimes. You might be new to turbo engines, you might be new to Audis, you might be new to engines in general, or you might know a lot about cars, but just this specific layout of engine you're just not sure on. So hopefully this video can clear up a few questions and help guide people through a few things. So this is the engine bay. Mine's a little bit different to normal, a few shiny bits, different airbox, but essentially all the standard bits you need to worry about are in here. So let's start with the basics. Air comes in here through the air filter, goes down here in the back to the turbocharger, gets whizzed round this charge pipe. You've got the turbo elbow at the back here, so you've got off the top of the turbocharger, goes to the charge pipe elbow here, goes around here, goes into here. It'll then go down to an intercooler that usually lives here, then an intercooler that lives here, and there's a crossover pipe that sits between the two big metal pipe, and then that comes up here, and then it goes through a hard plastic pipe down there which has got a map sensor on, and then into this pipe here, into the throttle body, into the inlet manifold, and eventually then goes into the engine. That's 101. So first thing is MAF sensor. This will usually be black. So the MAF sensor is a mass airflow sensor, and that's reading the mass of the air that is flowing over the sensor. So people often debate about cold air intakes and the volume of air, and cold air is denser and all that stuff. The MAF sensor does that for you, does that calculation for you, so you've not got to worry about oh, is it better to have cold air, is it better to have more air. You can measure what the MAF readings are, and it will tell you if the air filter that you've put on is giving more mass of air, so more oxygen going past that sensor than the standard airbox. The answer is stick a big filter on, just in case anyone's asking. But anyway, so the MAF sensor, it measures the air that's coming in. On here, got the N75. So the N75 valve has a feed that comes, now bear with me, I'm going to take this cover off and maybe this cover, give me 2 seconds. Okay, as if by magic the covers are gone. Right, where were we? N75. So this is the N75 valve. This is fed with charged air from here, and it's regulated, and then it goes down onto the wastegate actuator, which you can see just there, and that basically controls the level of boost that the turbo creates. There's a wastegate flap inside the turbine housing, and the N75 regulates that, so it keeps it closed when it wants to generate boost, or it allows it to open when it wants to regulate the boost. So the N75 itself, when we say unplug it, what we mean is just take that plug off there. Unplugging it puts it at wastegate crack pressure, which is, I'm struggling with my poorly thumb. Wastegate crack pressure is about 5.5 to 6 psi. So that's what, if the wastegate is operating correctly, with no additional help from the N75 valve, that'll open at 5.5 psi. That's to run a low boost mode. So that's often what the car will do if it wants to put you in limp mode. So when people think that the N75 is faulty, there might be something else causing the car to trigger the N75 to actually keep the car safe and keep it running at low boost. All right. But if you disconnect the N75 and you're seeing 10, 12 psi, your wastegate could be sticking shut. I mean, you'd probably be seeing a lot higher psi if it was sticking shut. Or if you're only getting 4 psi, you could have a weak wastegate, which would stop the car from being able to generate as much boost as it should do. So that's the N75. Next to that, we've got the diverter valve. I've done a separate video on this on how to test the diverter valve. Essentially what this does, with the help of, in standard form, the N249 system, it takes a vacuum source from the inlet manifold and it stores that vacuum in this chamber, and when the ECU wishes to, it can then close these valves. It can do all sorts of wizardry and basically use vacuum to pull up the piston that's inside here, which will allow the charged air that is in this system, instead of going around the system, it will send it back into the intake. Now that is usually done on throttle liftoff. Okay. Now the one safety feature of the N249 in general is that it could, if an overboost situation is there and controlling the N75 hasn't resolved that, the ECU could use the N249 to divert charged air. That's very, very rare that the ECU ever has to do that, but that is the one drawback to doing the N249 delete, in my opinion. I've got another video on that. So yeah, that's the diverter valve. So we've got these two pipes here, are obviously the feed for the N75 and the feed for the diverter valve. These are common to split. You know, people use the wrong hoses on them. They're common to break down. So yeah, the N249, and this is regularly deleted by a lot of people. You know, I've got a different video on that, but that's what all this rat's nest is. But essentially it comes away very easily. A few bolts to loosen stuff up, unplug it, and you can get that out of the way. And then you get access to the coil packs, and underneath the coil packs is the spark plugs. The coil packs are the common thing that can go wrong on these. Also the coil pack wiring can break down, as you can see there. Because they're right next to the rocker cover, they get very hot. So you can see that earth wire, that's what happens. But when that's happening on wires that are all next to each other and wrapped up, that's when it becomes an issue. Okay, that earth wire is not causing any problems how it is. Yes, it doesn't look pretty, but it's not that big a problem. Anyway, so following the air system round, these are the upper boost hoses, because they're upper in the engine bay, that's how people refer to them. The charge pipe that I was, the map sensor pipe that I was on about earlier, sorry, is under here. So that valve there is the map sensor. Now map sensor actually stands for manifold absolute pressure sensor. But that's not on the manifold, it's before the throttle body, so it's not strictly a manifold absolute pressure sensor. But what it is a sensor that can tell how much boost is in the system, with the pressure of the air of the system at that point. So the ECU was measured through the MAF sensor. It's measured what's gone into the system. It's then measured what's still in the system at this point. If you've got a leak anywhere on this point of the system, it will factor that in. Okay. If after this point you've got a leak, so anywhere around here or anywhere up here, if you've got a leak at any of those places, that's when the ECU throws a fit, because it's sensed that the pressure is there. It knows how much oxygen there's supposed to be there, but it isn't there anymore. So now that obviously the air gets read here and here with the MAF and the MAP. So when there's a discrepancy and a difference in the readings between the two, a lot of people disconnect the MAF sensor, and hey presto, the problem's gone, because it's only using one reading then, and it defaults to a slightly richer fuel mixture. So yeah, it can mask the problem. So a lot of people think, oh okay, I'll put a new MAF sensor on. Well, they're, you know, quite expensive, and a lot of the time not going to fix the problem. You know, the more common fault is that there's going to be an air leak somewhere. So realistically, you need, you know, VAGCOM, the free version of it, will be able to tell you if you've got a difference between the you know, requested boost and actual boost, and things like that, so you can try and get an idea if there is a leak in the system. You know, putting a boost gauging, you know, looking for, you know, a sensible reading of sort of around the minus 20 to 25 on a PSI gauge, you know, and you know, monitoring your boost as you go through the rev range. You know, things like that can actually help with diagnostics as well as looking quite pretty in the dash vents or wherever you choose to put it. But so yeah, when we're saying disconnect the MAF sensor, if that resolves lumpy idles, that doesn't necessarily mean that the MAF sensor is at fault. That means that further investigation is still required. Anyway, moving on. So the reason that that can happen a lot of the time is this PCV system that lives under here. Now on the underside of this manifold, you've got, whether we can show you, whether we can see down this gap or not, just there you can see a pipe coming off the inlet manifold. Okay, so that pipe that comes off the inlet manifold goes down into this rat's nest of piping under here. Now the PCV system itself is not overly complicated, but it is prone to failure. So on mine it has been replaced, but common places for it to split and crack are on these hard plastic joints. They're common to go around that area there. The pipe that says forge there, that's often a culprit. This little one here, that's the one that comes off the bottom of the inlet. That one there often cracks. And you can get these that are hard plastic. These can break down. Now the problem is, if this valve that lives in here, which is supposed to stay shut under boost, so while you're boosting, that valve there stays shut. When you're under vacuum, that lifts up, which allows the inlet manifold to draw in the ventilated air from the crankcase. But if that valve is allowing boost to go past it, then that can be, you know, part of a leak. If it's if that's opening under vacuum and you've got a split here or around here, which these are often, you know, culprits to go wrong, then it can be drawing in extra air into the inlet manifold that hasn't been measured by those two sensors previously. So that's where you get an unsteady idle and things like that. So when we're talking about the PCV system and the PRV system, that's those two valves there working in connection with each other. This valve, again, under vacuum, it stops the intake and the suction of the turbo being able to pull air through this system, because that valve will close. But off boost, then the cam ventilation comes through here, and that air goes back around into this system. That's where people put catch cans in, because that's oily hot air, which that going around the system isn't the best thing for it. Actually, a catch can is a really good tool to have, because it just catches the oil, catches the water vapor that's in that ventilated air. It stops it going back around into the system, keeps everything nice and clean. So we've talked about the air that goes around the system. Obviously you've got fuel that goes into the system as well. So the fuel comes in on these lines here to the injector area. You've got a 3-bar fuel pressure regulator here, which regulates the pressure of the fuel. What also happens is, when it's under boost, there's a nipple off the bottom of here which feeds directly to here, so you get 3-bar plus whatever boost you're running. So if you're running a bar of boost, then it'll then be allowed 4-bar pressure at that point. So it's basically just to aid higher pressure fueling as you go through the rev range and as you add charged air, so that the fueling can keep up with the air that's being added. And obviously then the ECU controls the rate at which it opens and closes the injectors. But you'll notice that the injectors are in the inlet manifold, which means the air that's going into the engine has got the fuel added to it before it goes past the valves, which is why on these engines things like you know, carbon clean and all that sort of stuff isn't actually as important, because you've got hot petrol filled air going past the valves. On a car where it's direct injection, where the injectors are actually going straight into the combustion chamber, yes, you can get carbon build up on the valves and things like that, but in these you don't tend to get it at all. That's not to say the engines aren't dirty once they've been in use for a long time, but the problem is nowhere near as bad. So that's the fueling side of things. A dead simple system there. You've got water gets pumped around the system, so you've got the coolant reservoir here. I'm just going to take this off. Now, I've talked you through in the past about the minimum and maximum coolant levels, which you can see on there, but if we take this off, there is a couple of other things under here that I can show you. You've got your power steering reservoir here. And when you take this out, there's a little markers on the dipstick that show you the levels. That's a closed system, so that shouldn't be changing levels. If it is changing levels, it means you've got a leak somewhere, so it shouldn't be changing levels. So here you've got the carbon canister. What this does is, on cold startup, it stores fuel vapor and just injects it into the system to help with a cold startup. If you've got an APX, you'll have a secondary air intake system. This is a BAM car, so that would normally be a silver valve sort of sat here, extra corrugated piping running around here. On the BAM engine, you've got this variable valve timing, which they both basically do the same thing. On startup, they allow more air into the system to heat the catalytic converters up quicker, to get things running more efficiently, more quickly. That's an emissions thing. So again, secondary air intake delete, it's not a problem. It just means your car takes a little bit longer to get up to the point where it's not killing polar bears. Okay. Let's think what else we need to go through. I really should have thought about this before I started the video. I think that about covers it for now. If you've got any specific questions, queries, please let me know. Let's have a quick look. Let's make sure we've gone through everything. So we've got the MAF sensor, we've got the diverter valve, we've got the N75, we've got the N249 system here. We've got the charge pipe elbow, charge pipe, the upper boost hoses. We've got the MAP sensor down here. We've got the inlet manifold. This is the temperature sensor for the inlet manifold. This is the throttle body, which is when these need a reset. Let's just leave the key in the ignition for ages before you actually start it. It just allows it to check the position of the throttle plate. That can sometimes be an issue if you've had it off to clean it and things like that, but generally not a problem. We've got the coolant temperature sensor, is just here. So to remove that, you just pull this plastic thing out, and then the sensor comes out, and you change it with the O-ring at all times. You never reuse an O-ring for that. We've got brake fluid reservoir there. What else do you need to see? I mean, the alternator's under there, the aircon system's under there, the power steering pump's under there. Got your gear linkages there. We'll do a separate video on a gear linkage reset. But no, I think that covers everything that we need to cover for now. So, like I say, any problems, questions, queries, pop them in the comments. I'll try and help out. But hopefully, if you've been asking questions and you're not sure on where things are, if I've directed you to this video, it's answered the questions that you needed to answer. Again, if it's not, just fire away. I'll see you soon. Cheers, guys.